NASA has recently unveiled fresh images of the Comet 3I Atlas, which might have revealed the most peculiar anomaly we have ever documented. These pictures showcase a jet emanating in a direction that should not be physically feasible for a natural comet, and it's not merely the sun-directed jet that we were observing earlier. In this video, I will delve into what these new images truly uncover and discuss why Dr. Avi is suggesting that this could be the evidence we've been anticipating. On October 2, 2025, the first Atlas made its way past Mars, roughly 29 million kilometers away. While this distance may seem considerable, it is relatively close in the vastness of space. Circling Mars is a NASA spacecraft known as the Mars Reconnaissance Orbiter, which is outfitted with a camera dubbed High. It's essentially the most powerful reconnaissance camera we've ever sent to another planet. When 3I Atlas approached Mars, NASA pointed this high-resolution camera away from Mars to focus directly on our enigmatic visitor. After waiting over a month for the images to be processed and released, we finally received them. These images revealed details we couldn't see from Earth. From our vantage point, we viewed the object at a specific angle, but the camera orbiting Mars was capturing it from a completely different perspective. This new angle provided us with a side view of the object that we'd been unable to acquire previously, leading to the discovery of something remarkable. The side view revealed that the anomalous jet we had been examining was behaving differently than we had thought for months. We scrutinized images that depicted what seemed to be a jet directed toward the sun. When Hubble captured images in July, the object was still approaching the sun from a significant distance. At that point in its path, the direction toward the sun and the direction of travel were nearly the same. When we observed the jet extending forward, we entertained the idea of an unusual solar heating effect. However, at the time of the new images, the path toward the sun and the travel direction no longer aligned. The high-rise camera viewed 3I Atlas from a completely unique angle, allowing us to discern what was truly occurring. The jet is not directing toward or away from the sun. Instead, it is oriented perpendicularly to the sun at a 90 angle, while the sun-directed jet continues to be visible, stretching ahead of the object in the direction of its travel. To grasp why this anomaly is so significant, we need to understand the three forces governing comet tails and jets: solar heating, solar radiation pressure, and solar wind. Importantly, they all originate from the sun. Solar heating occurs when sunlight warms ice pockets on a comet's surface, causing the ice to sublimate directly into gas. This creates jets that point back towards the light source. Thus, if a comet's jet contravenes toward the sun, it is undoubtedly the result of solar heating. In contrast, solar radiation pressure occurs as light from the sun pushes away small dust particles released due to solar heating. Dust tails always orient directly away from the sun, irrespective of the comet's direction of travel. Solar wind, a stream of charged particles emitted by the sun, similarly pushes gas away from the sun, paralleling the effect of radiation pressure on dust. Thus, gas tails also invariably point away from the sun. All of these forces derive from the sun, which serves as the principal source of energy and momentum, affecting comets. What, then, can we conclude when a jet points perpendicular to the sun? This indicates it's neither propelled by solar radiation pressure, nor influenced by solar wind, nor is it generated through solar heating. There is no known natural mechanism responsible for this occurrence. The term perpendicular refers to a 90 angle. The jet is pointing at right angles to the sun's direction. This is not a trivial effect. The jet stretches for thousands of kilometers, forming a primary structure maintained over vast distances in space. For it to remain columnated and directed perpendicularly to the sun, while the comet is in motion, simply isn't achievable by natural processes. As comets move through space, they spin. We might think about whether the comet is rotating, resulting in a jet that originally pointed toward the sun being redirected sideways. While this does occur, and we've witnessed it in various comets, when such rotation leads to lateral jets, they form spiral patterns. The jet will sweep through space like water from a rotating sprinkler, resulting in a curved tail or spiral structure. 3I Atlas has a rotational period of about 16 hours, as corroborated by light curve analysis. If a sun-heated jet were to deflect sideways due to rotation, we would observe curvature and spiraling. Instead, what we see is a straight columnated jet consistently fixed at 90 from the sun, extending an exceedingly long distance. We have analyzed thousands of comets and encountered every conceivable type of anomalous tail configuration, including curved tails, split tails, and disconnection events where the tail fragments, as well as anti-tails that seem to point toward the sun due to the geometry of our perspective. Yet, we have never observed a jet definitively confirmed as perpendicular to the sun. Each time we suspected a similar sighting, it turned out to be an optical illusion based on our viewing angle. When we observed from a different position or awaited a change in geometry, the jet revealed itself to be facing the sun or trailing in its wake. The high-rise image is unique because Mars was positioned ideally to reveal the true three-dimensional geometry. The camera collected images of 3I Atlas from a side perspective, while the Sun occupied a completely different position. Here, there is no illusion of viewing angles. The jet is indeed perpendicular. For this to occur, the jet source would need to be perpetually active and oriented perpendicularly to the Sun, even as the comet rotates. This suggests the necessity of either a highly specific geometric configuration that somehow remains aligned to the Sun's direction, which is physically not, as Dr. Avilo proposes, possibly necessitates active control. Renowned comets like Shoemaker-Levy 9 fragmented and exhibited intricate tail structures, yet were all aligned by the Sun's influence. Hale-Bopp featured multiple jets from various active areas, but each could be accounted for through solar heating of surface features affected by rotation. The interstellar object Oumuamua never demonstrated jets, contributing to the controversy surrounding it. However, 3I Atlas is displaying entirely new behavior. Dr. Low believes this to be a technologically advanced object. Even skeptics must acknowledge that we are witnessing anomalies that defy explanation under conventional cometary physics. NASA ought to be engaging in discourse about these inexplicable anomalies rather than solely concentrating on the established, familiar aspects. This new anomaly, unveiled after the protracted processing period of NASA's images, adds a further piece to the Atlas puzzle. A jet oriented perpendicularly to the Sun signifies a fundamental transgression of everything we understand about cometary dynamics, and its existence necessitates interpretations that transcend established physical models. Before we conclude, it's essential to remember the 12 points that defy any standard explanation. Make sure to memorize, share, and demand clear answers. Here's a comprehensive overview. 1. The retrograde trajectory aligns within 5 of the ecliptic plane. Natural interstellar objects can approach from any direction. Thus, the ecliptic plane, representing a minuscule fraction of all possible approach angles, indicates that 3I Atlas navigated a path that maximizes encounters with inner solar system planets. Moving against their orbital direction, the probability of this alignment occurring by chance is around 2%. 2. The persistent sunward and cometary tails typically trail away from the Sun, propelled by radiation pressure and solar wind. Atlas demonstrated a feature pointing toward the Sun across month-spanning observations. Although geometric perspective effects can yield apparent anti-tails, detailed analysis for this object has ruled that out. The feature is real, pointing sunward, with no conventional explanation for material streaming towards the star. 3. The extreme mass. 3I Atlas is roughly 1,000,000 times larger than Oumuamua, the initial confirmed interstellar object, and 1,000 times heavier than Borisov, while traveling faster than both. Yes, detecting interstellar objects becomes more likely with larger sizes, but the mass distribution of ejected planetary remnants from other stars should adhere to certain scaling laws. Discovering such a massive, swift object this early in our survey efforts suggests unlikely sampling, unless these objects are significantly more common than population models. Project. For the timing of its arrival, Atlas reached perihelion at a moment that brought it within tens of millions of kilometers of Mars and Venus. It traversed the inner solar system when Earth's viewing geometry rendered it unobserved from our planet during its closest pass to the Sun. It will reach closest approach to Earth weeks later, at an optimal distance for viewing. These aren't random alignments. The timing positions the object with multiple planets sequentially, as if following a tour rather than a simple ballistic path. The likelihood of this configuration occurring by chance is estimated to be about 0.005%. 5. The composition. Spectroscopic analysis reveals remarkably high nickel emissions compared to iron content. Natural, meteoritic, and cometary materials typically display iron tonical ratios around 10:1. Industrial nickel alloys, however, prioritize nickel for its strength and resistance to corrosion. 3I Atlas showcases a composition that mirrors engineered metal rather than natural rock, as its nickel-to-cyanide ratio vastly exceeds those of known solar system comets. 6. The water fraction only accounts for 4% of its mass. Comets are generally expected to be dirty snowballs, predominantly composed of water, ice with rock, and organic compounds mixed in. Typical comets present water content around 50% or higher. Atlas, on the other hand, is primarily rock and metal with a minimal amount of volatile ice, aligning more with an asteroid that somehow found itself on an interstellar path, albeit asteroids do not produce the gas emissions we are witnessing. This low water content has been documented through meticulous measurement of emission line strengths, failing to reconcile with standard cometary models. 7. The extreme negative polarization. The reflected light from Atlas shows unprecedented polarization properties for comets. The negative polarization branch, where reflected light becomes polarized inversely to the scattering plane, reaches amplitudes never before verified for any solar system comet, including Borisov. This suggests surface or coma properties that starkly differ from known cometary materials. Factors such as grain size, composition, or structure render Atlas's optical signature one we have not previously encountered. Probability stands below 1%, based on a comparison with the entire database of cometary polarization measurements 8. The arrival direction traced back to interstellar space. The trajectory intersects within 9 of the sky location from which the WOW signal emanated decades ago, representing the most robust candidate for extraterrestrial transmission ever captured. The coincidence of Atlas arriving from almost the same direction so many years later could be coincidental, with the probability around 6%. If the WOW signal was genuine communication or a leakage of radiation from an advanced civilization, sending a physical probe along that back vector would be a logical follow-up. 9. The rapid brightening near Atlas exhibited a rapid increase in brightness, outpacing any known comet. The light curve does not comply with established cometary models rooted in solar heating and sublimation rates. It also shifted in color, appearing bluer than the sun, while comets generally turn red due to dust scattering. This bluer hue is particularly perplexing, given the surface temperature should be thousands of degrees cooler than the solar photosphere, naturally leading to redder emissions. Achieving such blue color necessitates either an unusual composition or an internal heat source capable of maintaining temperatures higher than solar heating alone could produce. 10. The jet's surface area problem. Calculations based on mass flux observed in the jets and necessary solar energy absorption suggest that the nucleus would require an impossibly large surface area to facilitate emissions via thermal processes. The health of the jets is too vigorous for the size of the object. This implies either the sublimation efficiency is extraordinarily greater than any known material or that energy originates from a source beyond sunlight. Detailed analysis has quantified this discrepancy as significantly pronounced, by factors several times greater than what appears physically plausible. 11. The non-gravitational acceleration without breakup near JPL observed considerable thrust generated by non-gravitational forces. According to the law of conservation of momentum, creating this acceleration via outgassing would have vaporized no less than 13% of the total mass. For an object weighing 33 billion tons, that equates to over 4 billion tons of material expelled in roughly a month. This should have resulted in a massive, brilliant coma observable by amateur telescopes, as well as fragmenting the nucleus due to thermal stress and mass loss. Yet, neither occurred. The object remained whole with a modest coma, implying that the acceleration stemmed from efficient propulsion rather than excessive bulk evaporation. 12. The rotation paradox. Observing a 16.16-hour rotation period through photometry indicates jets extending over 1,000,000 km while maintaining tight collimation and fixed orientations. These observations are incompatible with passive outgassing from a rotating entity. The jets should exhibit spiraling, smearing, and clear rotational signatures. Instead, they persist in their orientation as if they are under control, emitted from directional nozzles compensating for the spin, as though the rotation serves an alternate function, perhaps creating artificial gravity. While propulsion works independently, each anomaly stands alone as a serious issue. But together, they create a riddle that challenges conventional models. Simply pointing to an instrumental flaw and moving on will not suffice. The situation calls for thorough investigation and verifiable data. What are your thoughts? Do the numbers, images, and signals persuade you that we are encountering something beyond natural phenomena? Or do you lean toward an extraordinary explanation derived from conventional cometary physics? Please share your thoughts in the comments. I read everything. Also, consider sharing this video with anyone who enjoys space mysteries. Comment and share. Until next time, remember to look up with both curiosity and critical thought.